Hello everyone. Next type of motor is single phase motors. So as the name suggests, these motors are used on single phase supply. So the most common type of electrical motor is the single phase type, which finds wide domestic commercial and industrial applications. So domestic applications like fans, hair dryers, washing machines, vacuum cleaners, mixers, refrigerators, food processor, etc. So single phase motors are classified as induction motor, commutator motors, and synchronous. So a single phase motor consists of single phase winding mounted on the stator, each winding on the rotor. So when single phase AC supply is connected to the stator winding, a pulsating magnetic field is produced. A pulsating field means the field builds up in one direction and falls to zero and then builds up in opposite direction. Because in single phase AC supply, if you see the waveform of single phase AC supply, it will start increasing, reaches to zero and changes its direction and increases in opposite direction and again zero. So that's why alternating current is alternating one that it changes its direction. So the alternating flux is also means that flux created by the alternating current is also alternating or pulsating. So it changes its direction. So it builds up the torque in suppose positive half cycle. So in positive half cycle, then the torque produced by the single phase supply is suppose in this clockwise direction, and after half cycle it will changes its direction. So it will oppose that is, it will changes its direction of torque in opposite direction. So under this condition, rotor does not rotate due to inertia because it is a heavy weight rotor. So it will not move, but it will what do you say? So the under these conditions, rotor does not rotate due to inertia. So therefore, a single phase induction motor is inherently not self-starting because it will not automatically start it and automatically starts to rotate like a three-phase induction motor and requires some special. However, if the rotor of single phase is rotated in one direction by some mechanical means, it will continue to run in the direction of rotation. So suppose if we rotate, suppose the direction of rotation in half cycle is suppose clockwise. On that particular instant of time, if we rotate that rotor in this direction, then that clockwise torque has a value much more than that anti-clockwise torque. So it will start and vice versa. So in order to make the induction motor self-starting, it is necessary to produce a rotating magnetic field. So in order to produce rotating magnetic field, we required a minimum two fluxes, two magnetic fields, which is 90-degree space apart. So for production of rotating magnetic field, there should be at least two magnetic fields which satisfy the following two conditions. That is, two magnetic fluxes should be shifted by 90 degree with respect to in space. That is, if one flux is horizontal, then other one should be vertical. That is, in between there will be a 90-degree phase shift. And the second one is the two magnetic fluxes should be in time potentials. Also in time potential, that is in space and time. Uh, these fluxes also 90-degree phase shift. So a single phase stator winding cannot satisfy these two conditions because there is only one winding which can produce only one flux. For this, some modifications are done. So we split that single winding into two winding and creates a rotating magnetic field. So there is a theory behind this. So the first theory is double revolving field theory of single phase induction motor. In this double revolving field theory of single phase induction motor states that a stationary pulsating magnetic field, that is the AC waveform is like this sine wave. So it will produce a torque either in direction for first half cycle and in second in opposite direction for next half cycle. So rotor does not move. So that pulsating magnetic field can be resolved, splitted into two rotating magnetic fields, each of equal magnitude but rotating in opposite direction with synchronous. So the induction motor respond to each magnetic field separately, and net torque in the motor is equal to the sum of torque due to each of two magnetic fields. So suppose this first half cycle, the direction of flux produced by this in direction anti-clockwise. In second half, the direction of rotation is this direction. So the resultant flux will be phi. So it we say that the main magnet can be resolved into two rotating magnetic field, each of equal magnitude. That is phi. One magnetic field is phi m by two, and second magnetic field also have same magnitude, that is phi m by two, but in opposite direction. So one magnetic field is rotating this direction, second magnetic field in rotating this direction. So net torque will be the sum of torques due to each of two magnetic. So when the rotor is stationary, that it at standstill, the induced voltages are equal and opposite. So consequently, the two torques are also equal and opposite. Hence, at standstill, the net torque is zero. In other words, single phase induction motor with single stator winding inherently no has torque. So if the rotor is given an initial rotation by auxiliary means in either direction, the torque due to rotating field acting in the direction of initial rotation will be more than the torque due to other rotating field. Suppose if we move the rotor at the instant of, if there is a force of clockwise direction, if we move the rotor at that particular instant, then the rotor starts to rotate in this direction. Hence, the motor will develop a net positive torque in the same direction as initial rotation. The motor will therefore keep running in the direction of initial rotation. So, in order to make the single phase motor self-starting, the two windings are provided instead of one. That is, the axis of stator winding are displaced by 90-degree electrical and winding currents are 90-degree phase shift in time phase with respect to each other. So we call it the split phasing principle. So there are two type various methods of obtaining this phase shifted current. So basically, in this your syllabus there is a resistance split phase motor and capacitor split phase motor. So that single winding is splitted into two windings and placed at 90-degree to each other in space and time in order to produce rotating magnetic field. The first motor in this case is split phase induction motor, that is resistance start motor. So there is a, and this is a main winding and this is the starting winding or auxiliary winding placed at time. So in this, it has a single cage rotor and its stator has two windings, a main winding and a starting auxiliary winding. So main field winding and starting winding are 90-degree displaced in space. So main winding has very low resistance and high inductive reactance. That is, this main winding has very low resistance and high inductive reactance. That is, inductive property is high in main winding. Thus, current IM, that is magnetizing current IM in the main winding lags behind the supply voltage by 90 degree. The auxiliary winding, that is starting winding, has high resistance and low inductive reactance because it is highly resistive made, so that the current I is nearly the same in nearly in phase with the line voltage. So this phase difference is enough to produce a rotating magnetic field. This is main winding is highly starting winding or auxiliary winding is highly resistive. If we give a supply, then it will create, suppose this is a phasor diagram of voltage supply voltage. So in main winding which is highly inductive, it lags nearly by 90 degree, this is IF, so lags or behind the voltage and auxiliary winding is highly resistive, less inductive, so it is lag or nearly in phase with the volt supply voltage. So there are two fluxes now. There are two current, that is starting winding current and magnetizing main winding current. So that two currents creates a magnetic field which is uh, phase difference by some angle, which is sufficient to produce a rotating magnetic field. That rotating magnetic field creates is sufficient to start the induction. So main and auxiliary winding are connected in parallel during starting. So the starting winding is disconnected from the supply automatically when the motor reaches speed about 70 to 80% of synchronous speed. So this there is a centrifugal switch we use. So this starting winding is used to only start the induction motor, and main winding remains in the circuit all the time. So if this motor reaches the 70 to 80% of its speed, then this centrifugal switch automatically opens, and this starting winding is cut out from the entire circuit. So the split phase induction motors are suitable for easily started loads where frequency of starting is limited. That is, the common applications are washing machines, air conditioning fans, floor polishers, blowers, centrifugal pumps, small drills, and lathes. So next is a capacitor start motor. So in the next lecture we will study the capacitor start motor. Thank you.